To create a simulation, enter the stress analysis environment. The typical workflow involves creating a new simulation and selecting the loading, constraints, material, and contact values to apply. This simulation uses the default settings for the simulation type. Since there are no moving parts to be considered in this assembly, you can generate contacts automatically. This process can take a few seconds to complete. A review of the contacts folder shows that the default type of bonded is acceptable for this simulation. The next step in the workflow is to apply the required material to each part. In this example, the high-strength, low-alloy steel selected in the part environment is correct. Note that it is possible to override the default material for a simulation to easily test and compare results using different material options. The assembly is attached to a cylindrical drum, so a fixed constraint is required on the end face of the cap. Using the pressure tool, a load is applied to the inside face of the end cap. For this simulation, we'll use a pressure load of 375 psi. When the load is applied, a display glyph indicates the general location of the load. This value is based on the expected operating conditions. Wind loads are the biggest loads these products will experience. In their harsh and windy environment, the solar arrays act like a big sail. Equipment loads themselves are usually only 4 to 5% of the wind loads, so if you meet the structural requirements for wind, all other requirements will be met. The simulation can now be run. Depending on your computer, this may take a few minutes to complete. We'll be checking the simulation results against our design requirements. We're looking for a minimum safety factor of 1.5, so that the design is built to safely handle 1.5 times the stresses caused by the maximum expected load. You can calculate a factor of safety as the ratio of the maximum allowable stress to the maximum stress the part will ever experience. In this design, we're using yield strength as the maximum allowable stress because we need to avoid any permanent deformations. The yield strength for this type of steel is 40 ksi. So to get a safety factor of 1.5, we can never exceed a von Mises stress value of 27 ksi. We also want to make sure the displacements aren't more than 0.02 inches. For each simulation, we'll be checking against these values. The maximum stress value is 13.45. The maximum deformation is 0.05992, and the minimum safety factor is 2.98. As each set of results is reviewed, the location of the maximum and minimum values can be probed. To determine the mass of the new design, you exit stress analysis. As we can see in the eye properties of the assembly, the mass is currently 565 pounds. This is a reduction of 85 pounds from the original flat end cap design. To visualize the effects of the pressure load, animate the simulation for the stress, displacement, and safety factor results. In conclusion, we are safely within the design requirements. There is likely more that we can do to further reduce the mass.